Okay, next in class we talked about inverses. Inverses are two functions that are complete opposites of one another. We showed a graph in class that showed that if you graph inverses, in fact, I recommend if you weren't there, do this in your graphing calculator. Put your two functions in your graphing calculator and graph them. They make mirror images of each other. They're reflections of each other across a 45-degree angle line right there at the line y equals x. It's kind of a weird thing about it. So the first thing we did is we talked about how to test to see if two things were inverses. We did f of g of x and g of f of x. And if when you do that, if you get x back out for both of those, that tells you that you have two functions that were inverses. So we did that. You can see the work down here. We took the g function, we picked it up, and we plugged it in for x in the f function. Those 4's canceled. You're left with x minus 2 plus 2, which is just x. The second one, the plus 2 and minus 2 canceled. 4x over 4, the 4's cancel, and you're left with x. Okay, next thing that looks like we did is we had another function, only this time I gave you a function with a radical and another function. Before we started, you got to establish what the domain is, because your inverses are only going to exist where each function exists. And because this is a radical, x can only be greater than or equal to -1. So this graph doesn't even exist below -1. So these two functions are only going to be inverses where x is greater than or equal to -1. And you can graph those in your graphing calculator. You'll see what I mean. You'll notice that they are reflections. We did this in class. They're reflections of each other except less than -1. Then they don't reflect because this one's not there. But we showed the test again. We picked up the g function. We plugged it into the f function. The plus 1 and minus 1 canceled. You were left with the square root of x squared. Squareds and square roots cancel each other out, and you're left with just x. The g of f of x, you pick up the f function and you plug it into the g function. It looked like this. We had that square root squared. When you square a square root, this is what my slash is showing you, they cancel each other out. They are opposite operations. So you're left with just what's inside, x plus 1, minus 1, and that just gives you x. So we've tested and we can verify, yes, those two functions are inverses. The next skill we did in class involved finding your own inverse. And so the steps that we did, first step we rewrote that f of x as the letter y. So what you can't see here is what was erased. So I'm going to write it off to the side. So that's step 1. We change that to y equals 4x minus 3 over 5. So that was our step 1. Rewrite that f of x as the letter y because they are interchangeable. So step 1 was make sure you have the letter y in there for f of x. Step 2, which you can see illustrated here with the green marker, is we switched places with the x and the y. So we picked up the x and y, we switched places, and that's why you see those in green here. And then one by one, our goal was to get the letter y all by itself. So what I checked here is to show there are 3 things we had to get rid of. The 5, the -3, and the 4. And you have to get rid of those in proper algebra order. So the first thing you have to get rid of is the 5. So you do the opposite. Instead of dividing by 5, you multiply. So we multiplied both sides by 5. You got 5x equals 4y minus 3. Then we did the opposite of minus 3, and we added 3 to both sides. That gave you 5x plus 3 equaled 4y. And then we divided by 4. You have to divide the whole left side by 4, so make a big old fraction bar. And that's our inverse. So we just created an inverse. We could test that by doing f of g and g of f. But we already know we did it correctly, and we know we would get the same. Or if you graphed them, they would be mirror images of each other, which is kind of cool. And this is the last problem we did in class. We did one more where you had to find the inverse. So we started with this function in black. And you see step 1 illustrated in red, which is just change that f of x to the letter y. Step 2, we changed places with the x and the y. That's why they're in blue. And then we started the process of getting y by itself. We had lots to get rid of. Okay, so all this stuff is being squared and multiplied. Those are pretty tight connections. So the first thing you get rid of is that minus 5. You do the opposite. We plus 5 to both sides. We had x plus 5. Left with 4 times all this stuff. All this other stuff is squaring something is a higher ranked operation. So you get rid of that 4. So you got to divide. You got to do the opposite. Right now you're multiplying. You have to do the opposite and divide. She divides both sides by 4. So that's what we did there. I'm going to go ahead and shrink this like we did in class and move that and pull the others up. Then you see what we went to on the next step. Because we had that y minus 2 squared, we had to square root both sides. So we did that. We did the square root both sides. Notice the square root and square cancel. That got us down to y minus 2 equals that radical. And then you had to add 2 to both sides. And I gave everybody a warning in class and reminded them that plus 2 is not inside the radical. That 2 was not over there when you took the square root, so you can't put it inside. You got to leave it outside. So that's kind of ugly, but that's what it is. That's our inverse.